So, part 2, and I found my exam without revealing the new exam to the entire class. That's good. Oh, don't remove my Bitwarden. Okay, so let's go ahead and take a look. Right, this looks very familiar to a lot of you. The glossary for last year is a bit different than the glossary for this year, which we just posted. Good test taking tip would be to try and do a diff, because that's probably going to reveal the most information. This exam, right, this started with a bunch of pretty easy questions, kind of getting into the history and landscape of game dev. These come a lot from the early discussions that we had about game engines in general, about the history of game engines. You've got, right, what kind of vernacular, what kind of diction model do we use to theme our game engines around, right, theater? And, scene is a very good way to represent a collection of actors who do things with scripts. So scene is the first question. That was kind of a give me. Thank you, Donna. Yes?
The screens are still on.
Oh. I'm on a roll. Oh. I can't wait to stay up till like 1 a.m. printing tonight and then watch the Nintendo Direct from like 3 a.m. to 5. Disappointing?
It was so really good.
Really good?
Moo for Mario Kart.
But the price is
Nothing else.
It was $80 for a Mario Kart game.
$80, huh?
Yeah, but you're going to buy the bundle anyways.
Hey, stop with the spoilers, people. Stop with the spoilers, okay?
Don't expect it's on the first party.
Yes.
Don't expect anything.
All right, okay. Well, you know what I expect?
Nintendo Switch has Nintendo Switch has
Nintendo's able to PS5.
Okay. You know, the thing is that Nintendo always has a good console, like the Switch, and then their next console is pretty bad, like the Wii U. Or in this case, possibly the Switch 2, okay? Maybe they'll fumble it somehow. Never lose faith. Well, anyway. Okay, right? But you've got questions about Unity. You've got questions about Unreal, their unique position in modern game development. Questions about, like, why would someone want to choose a certain type of engine, right? Stuff like that, okay? Some quick things about data-oriented design, some quick things about license. Do you remember your licenses? Do you remember why people get freaked out about GPL, right? That kind of stuff is important, okay? And it's also extremely interesting. The best way for you to commit something to memory is to attach it to an interesting story, okay? So if you have a problem remembering what GPL is for, remember the poor Stepmania team accidentally choosing it and the chaos they had to go through to fix it later, right?
This is maybe not something you know, but what is the copyright law like around APIs and games? It's like,
well,
if you were to
yeah.
put the money in
Okay.
to make Unity,
So there was a question about exactly this. It came up in Google versus Oracle. And if paraphrasing the case, which I don't know the outcome of, basically Google implemented a lot of Java APIs in their own kind of language, I think called Kotlin. That was used on Android. Oracle got very litigious. That's their style. And I'm not sure what ended up happening.
Google won.
Did they?
Yeah.
Okay, so APIs, I guess, are not copyrightable, at least in that case.
Well, they are copyrightable, but Google went through a full clean room reverse engineering.
Okay. Well, APIs are not something you have to engineer, right?
Yeah,
Like, they're
the
usually
thing is that
public.
What Google did is, the whole point of that case was how did Google get the information about the APIs? They did a clean room reverse engineer. So they gave one person the code for the Java code base, said, hey, go reverse engineer this, go decompile it, and then that person will write down notes about
You mean they had the binary?
Yeah, because you
Okay.
have they have the binary.
This is ridiculous.
Anywhere.
It's like, you're going to tell me that this person in this clean room has never once written some Java?
No, or has, but
Like-
the whole thing is like he's got the binary for like the Java JVM.
Yeah.
So he'll go and he'll reverse engineer that, He'll decompile it all, and then that person will write notes on what the internal API looks like.
Oh, the internal API.
Yeah,
I thought
and
this was about the public
No,
API.
it was about the internal.
Oh, interesting.
Then
Okay,
he'll hand it
got you.
over to someone
Okay.
else who will implement them.
All right, I appreciate it. Thank you. Interesting case. You should look it up. Okay. So, why do you make certain choices as a pragmatic, game engine user? Okay, a lot of these questions in the early going, pretty easy, pretty light, a good way to get into it. We have everyone's favorite pyramid. It's gone. You bullied the pyramid, and it took its ball and went home. So now you're going to get something way worse. Yes?
The only thing about the pyramid that pisses me off is that the text boxes get bigger, but it doesn't cleanly get, like, the text doesn't cleanly get bigger. If you just switch to the penultimate two, it would be perfect.
If I reversed this, it would be aesthetically pleasing to you.
Yes.
Is that the problem? It's the only problem with the pyramid. Okay. So a lot of things in here, like, do you know what Lua is? Right? It's a language, but what kind of language? Is it scripting language? If I was really wanting to make this a more hardcore problem, I would put in another language in there, but it would be like a more core programming, systems programming language like D or Rust or something like that. Of course, we don't talk about those, so there's only one other language I could choose. It's C++, and that's not very hard either, right? Okay, all this stuff, like, do you understand what a B2 world is? Did you make it to homework 8? Did you pay attention a little bit during that lecture where we discussed it, right? Not too tough, any of this. Here we get heavily into the game engines. This is where your game engine of the day knowledge comes in, all those flashcards. You don't have to remember everything. You can use process of elimination, and then because this is matching, there's a decent chance you get it right just by guessing. And using the name of the engine can sometimes clue you into what its main properties are. Okay, and so not too bad. I wouldn't worry too much. And if you muck this up, it is not a huge point loss, just a couple points. More engines. Okay. In fact, 3 pyramids full of engines. Okay, that's quite a lot. I don't know if it'll be the same amount on this time, but you will want to know your engines. This is one of the more interesting sections about C++ and IDE pragmatics. This is where we ask whether, through all of your trials and tribulations, you have actually gotten a feel for how to figure out your own linker and compilation issues. The distinction, what is a compilation issue versus what is the linker issue, okay? Versus what is the dynamic linker issue? How do you make them apart? Does anyone know? No?
Dynamic linker issues will happen during runtime.
Yep.
Regular linker issues like, oh, we can't find this file. Or like it's a file not found, and then compiling it just you forgot to set a code or something like that.
Yep, that's mostly right. So dynamic linker is the build finished. All right, everything is fine, but at runtime, we need to find one more DLL or library and link it in dynamically. The operating system provides the support for that. It kind of patches our binary together while it's running. Dynamic linkers are a great way to update a C++ program while it's still running. Okay, people think about hot reloading languages that are dynamic, scripting languages like Lua or Python or JavaScript. You can do it with C++, okay? It's just a big pain. Anyway, compilation issues are where the compiler or possibly the preprocessor cannot make heads or tails of something you've said. If you are in the middle of your main.cpp and you write hello with nothing else on the line, right? The compiler is going to try and figure out, is that a data type? Is that a class somewhere? And if it can't find anything, it's going to explode, okay? And so we just can't compile this. We don't know what you meant here. We can't finish the build. We got no binary that we can really create. The linker issue is when you've defined things, but you haven't implemented them. This is when you get a message like what we have right here. Undefined reference to some sort of symbol or function, okay? We know that B2 world, the constructor, exists, but we weren't able to find it, okay? And as a result, we cannot continue the compile, and so that's a linker issue, okay? you can often get a hint. So for instance, in the screenshot, so you see LD, right? That kind of gives you linker vibes, right? And down here, where we've got a compilation issue, we see C3861, C, compiler, okay? These systems are trying to give you more information about where the problem is happening, as that will help you solve it. Right here, ladies and gentlemen, hey, you can continue to talk, just keep it kind of soft, okay? And we're all good. Okay, right here in this image, you can see DYLD, dynamic load, or dynamic linker, okay? So the answer is kind of abbreviated in pretty much all of these images, these screenshots, and so you can work from there if you notice it. Down here, we have a question that gives you a file system structure, and it asks you, well, how do I make this code compile? Okay? If you can see, our main project is kind of at the root here. Our main.cpp is right here. This is a Windows build situation. We got a third-party library that has 3 libraries in it. Now, we have 2 includes that go from this base route into the third-party folder, okay, and into library B and C. So a reminder of how this works. The preprocessor is going to run into one of these include statements, and it's going to try and find exactly the path that you list out, and it's going to look at multiple different locations, depending on what you configure. So right here, for instance, on the next screen, Donna configures the project directory, the root, to be one place that the compiler should look. So what's going to happen is that we get to include third-party library B. Okay, it's going to go, okay, third-party, can I find that? It's going to look from project directory, so it's going to look right in here. It's going to find third-party. So after finding that, it has to find the next part of the path, library B.h. It's going to look inside there, and it finds it. Boom, success. The line worked, the preprocessor is happy with us, and it moves on. This very first line is a problem, okay? Because it's going to go include library A.h. Donna provides project dir, so it's going to look in here. Do you see a library A.h file in this folder? Do you see it? The preprocessor is going to freak out. It has nowhere else it knows to look. And so it's going to fail. You fix this by adding this second string, okay? Project dir, third party. So now, when the preprocessor hits this line, it's going to look for library A.h, and it's going to first look in this project directory. It doesn't find it. Thankfully, there's a second place it was told to look. It's going to look in this third-party folder. So it goes into the third-party folder. It looks in here. It finds library A.h. It compiles. Boom. Good. Move on to the next line. Okay. So I know from office hours that a lot of you still don't feel very good about this kind of stuff. Go find some YouTube videos. Go find some tutorials, okay? Get a better feel for what kind of flags exist in Windows, OS X, Linux. Remind yourself, how did you configure this stuff? Okay, what did you write? What is your algorithm for trying to diagnose these issues? And I think you'll be okay, all right? Okay. Data structure question. You got some basic requirements. What kind of data structure might you choose? Here you got some options, and you just make a good choice. Basically, you just need to map an actor to some sort of ID, all right? Network ID, whatever that is. You want it to be fast. You do not need to order it. You don't need to iterate through it. So unordered map, very good choice, okay? Other choices are awkward or slow, and so that's not what you want. Here, we give you this code. We give you this object-oriented code, a character with HP, defense, speed, rel? What is that? Relationship? I don't know. And vel. And you're given a computation that only involves defense. That is it. All it does is print out damage amount minus the defense. That is it. Okay, so loading all of this data just to do that is very wasteful. Okay, so you're tasked with kind of breaking out this information, which we do here. In reality, the only thing we really had to do is break out defense. All right, we do the iteration, and we print the result of that computation. In this one, in this data-oriented version, we're only loading the defense values into cache. We have a strong expectation that's going to run significantly faster. Okay? Yeah.
For this one, this would cause a compile error.
Where?
You can't define arrays without telling it the amount of space the array is going to take up, or giving it an initializer.
The good news is that this is magic. It just works out. Don't worry about it. It's all good. Okay? Yeah.
It would be a vector. So
Improve cache utilization. I could make it a vector, but yeah. Oh well. Yeah. Yeah, I guess you can say some of this is pseudocode-y a little bit. No, you don't really have a choice. Maybe I'll make some edits tonight, though. Okay, anyway. All right, and then I like this question a lot. It's like, do you know what you just did? Can you describe it to me? What's the name for this thing you just did, right? Because it doesn't say to write a data-oriented version. It just says write a cache-efficient version. And then, oh, by the way, what's it called, right? Interestingly, like this is brought up on the first page of the exam. So if you forgot about what it's called, like hopefully that jogs your memory, okay? That's another good example. If you forget Lua syntax, guess what? There's a bunch of Lua code we provide on the exam, right? So one good tip is like, can you look at other questions and get some hints as to what's going on there? So anyway, yeah, all good. So here's your first Lua question. Up until now, most students are kind of like blazing through the exam, probably finding it pretty easy. This is the first time you actually have to write quite a bit of code, okay? This is kind of a fun, kind of arcade-style continue screen. If you've ever gone to Pinball Pete's, you might have seen this. If you've played a fighting game, there's a chance you've seen this. Basically, back in the day, arcade machines had a really tough time balancing difficulty. They had a really tough challenge. They did it really well, but it's a very difficult challenge. The arcade machine has a business model where it wants to take money from you every 5 minutes or so. They don't want you to play too long without getting money because they can only take a certain amount of money each time. And if you're playing for a long time, you're hogging a machine that a worse player could be playing and giving more money for that amount of time. What's more, your arcade machine cares about customers, but your main customer isn't the player. Who's your main customer if you're making an arcade machine?
It's the arcades.
It's the arcade owner. You know what the arcade owner wants? Good gameplay, but what they really want is what? Money. Yes, yes. Which arcade machines are most profitable per minute? And that's the machine I'm going to put in the best part of my store. Most prominent location, okay? I'm going to buy the most cabinets quantity of. And so in that era, you really had to make the games pretty difficult, but you didn't want to make them too difficult, okay? Because you want it to be very satisfying and you want the gameplay to feel, mostly like the player messed up, right? And if the player does mess up and, you've made the game likely they're going to mess up. It's a very hard game, all these arcade games. You want the player to be very excited to try again and get back into it. Put a quarter and keep playing. You even sometimes want to guilt trip the player into trying again. And this is kind of part of this right here, okay? So anyway, continue screen, if you haven't seen one, is basically where you mess things up and you get like a timer or something to choose if you want to try again or not. In arcades, this is a timer that allows you to stick quarters in because sometimes you're fumbling for your quarters and you drop them on the ground and that stinks, right? The game doesn't want to end if you're just about to pay them to keep playing. But if you're not going to pay them, they do want to end quickly so that the next person can step up and start fresh and have a great time and pay money, okay? Anyway, you just implement this, okay, in Lua. You get a bunch of checkboxes here, and I encourage you, some students did this, some didn't. as you implement features, as you confirm them, they're going to work, okay? You simulate them in your head in the code, scratch off the checkbox. Mark the checkbox so that you know you've accomplished this part of what you need to do, okay? Write the Lua component in the box, please, not outside the box. Your Lua code needs to be valid Lua code. You can make use of the common lifecycle functions from lectures. So things like on update, on destroy, on start are all available to you. And then you start getting directions. So this component, very simply, it immediately begins playing an audio file called continue, okay? It doesn't tell you what channel to play this on. So what channel should you play it on? You know?
0.
Noah?
0.
0 is totally fine, but if you chose 1, you're good. If you chose 2, you're good, okay? If it's not defined, I can't really take points for it, okay? So you can do whatever you want so long as you play it as looping. Every frame, you need to draw a countdown number. This is the big number right here at location 500, 100 with a font default and size 50, okay? So these function calls, they're telling you to make a particular call, and you can go to the glossary to find out how to make that call. So text.draw takes parameters in the order the string message, the content, int xy, the font name, okay, the size of the font, and then if you want to tint the font, okay? The question says nothing about tint, so you get to choose, all right? The example in this image is white, but that's the default tint. Okay, countdown must begin at 9. Every 60 frames, it will go down by 1. So you need to use on update to actually make some sort of counter go down. Okay, some way you want to do that, make a variable go down and then print that new variable, okay? You need to render a different image for your main character based on what that countdown state is. So if it's larger than 0, then she's kind of standing up, she's all good. If it's smaller, you're gonna have her sit. And if the player presses spacebar, then she needs to go into the yay, let's try again pose, right? Okay, you've got some other stuff, blah, 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 some other text stuff that you have to do. And then the component requires that you don't pollute the global Lua space, okay? You do that, you're probably losing 1 point, not the end of the world. But just make sure that you're meeting all these requirements. And at the end of the assignment, when you have written up your code, just go back through them all and double check them again, okay? Make sure what you wrote does the thing and does so in a clean, obvious fashion with good handwriting that I'm not gonna mistake, okay? All right, and if you wanna know what that looked like for me, you can kind of see that here. Nothing too crazy, just some if statements. Last year, we had reports of students who would start writing, discover that they had different ideas, but they were running out of space in their table, in the box. So be careful, and if you have a general algorithm, it might be wise to write some pseudocode first, okay? That can kind of get your structure right, get your if statements right, so that when you want to go and finalize it, you can just kind of go back in, write it up, and you probably won't make any mistakes that need a big shift or a bunch of erasing. Nasty, okay? Not very fun. 100-meter dash. This is kind of a harder Lua problem, in my opinion. It's a bit more subtle, okay? Yeah, all the normal stuff, valid Lua code, all that. There are multiple actors in the scene named runner, okay? Multiple actors, they all have the same name. There's a function for that. You implemented that in homework 7. It's find all. Actor.findAll. You provide a name and it gives you a table full of those actor references. Okay, very nice. No actors will be instantiated or destroyed during runtime, so you don't have to worry about any being added. You may assume each actor has a transform component with X and Y. Okay, awesome. So you can grab that to manipulate where the runner is going to be or check where the runner is. Okay. Other components in the game will actually move the runner around. So those edit the X and Y values. You just need to read them. The race does not begin until global variable go is true. It begins as false. A different component of the game will set it to true, and then it will be false. At the very end of every frame, after all other components have had a chance to run, okay, if you see something specific and weird like this, it's almost trying to get you to remember something or use something very specific. In this case, what does it want you to use?
Late update.
On late update, right? Have you forgotten that exists? Well, this is your question where we're going to give you some points if you remember it's a thing, okay? So use on late update, okay? And check each runner's X and Y position, okay? All other runners in the code base use on update in their logic, and that has an implication, right? Everything's going to be updated there. If any runner has an X larger than 100, print them as the winner, and then application to quit, okay? Each runner starts at .x equals 0. If any runner has a .y that's more than 0.5 away from their index in the table, returned by actor.findAll, right? So 1, 2, 3, 4, 5, right? Declare that runner disqualified, debug.log, and never check them again. What is this implying? This is implying use of a particular function involved with tables. If you're keeping track of all the active runners, then this is where you use table.remove, right? To remove that runner that just got disqualified. In this way, you will never check them again. But there's a problem, because what happens when you remove something from a table?
You gotta do it later so you're not looping through.
Yeah, you got to be careful, because you don't want to be iterating through that table and then remove the runner from the table that you're currently iterating through. That will really mess up your code, and some students forgot about that, right? That kind of gotcha. A very important one, a very easy bug to write, but something to keep in mind, okay? Blah, 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 blah. Careful, right? Oh, yeah, and it even reminds you here. Very nice exam. Altering a container while iterating through it can lead to havoc. And keep everything local, right? So this is my solution here. I actually think I had one solution, but then I read a student's solution on their exam, and I thought, oh, this is way better. It's way cleaner, way shorter, much nicer. And so I changed the staff solution to that. You have a table that's keeping track of all of the disqualified runners, okay? You have onStart equals function self.runners. You find all those runners. You put them in the runners table, okay, very good. You mark all runners as being not DQ'd, okay? We could put a new Boolean onto each runner and check it via that. But what I actually did is I simply put them into this disqualified runners index, or actually I put a Boolean in. So this is kind of a data-oriented way to do this in Lua, which probably gives you no performance benefit at all. But that's how it is. Anyway, yes?
How would you like add like a DQ property to the thing? Would you just do self.runner @I at DQ or whatever?
Yeah, so this actor right here,
How to like add something to the
yeah.
actor.
So this actor is going to be iterating, right? So this loop iterates us through every runner,
Yeah.
okay? Each runner is a table. And so what we could do is go actor.dq equals false, and that will add that Boolean onto the actor.
If it doesn't exist, it'll add it.
Yep, that's right.
Okay.
Yep. So this is something that in C++, the compiler would go nuts if you're trying to do this. But remember, Lua is a very nice, soft, loose, dynamic language. It wants you to get crazy like this, okay? This can lead to bugs, but it's also very powerful and very fast. You can script very quickly this way. Anyway, we now have a data structure that uses an index to look up whether a particular actor is disqualified or not, okay? On late update, which allows us to kind of check at the very end of the frame when everything is already processed for the frame, we can check if go is equal to false, and if go is not true yet, we can just return. Okay, very nice. Every frame, we're going to check all the runners that we know about. So we do I-pairs to go through our runners. We can check if that runner is disqualified or not. And if they are, we just kind of continue on to the next actor. We don't do anything else. Okay, this is kind of a way, this is an alternative to using table.remove, actually. so we don't have to adjust the table. That's really nice, actually, right? That gets us out of our bug. Maybe it's not the most efficient. It uses more space. When an actor is disqualified, it might be nice if we could just get rid of it and free up some memory. But this problem doesn't require that to happen. So we grab the transform component of the runner. We use math.abs, which I think is in the glossary, to check how far is the runner away from that position it needs to be at, the index, okay? If it's larger than or equal to 0.5, the runner has kind of stepped out of their lane. So we're going to disqualify them, announce them as disqualified, set their disqualified runners array index to true, and now that will cause us to skip them, all right, forevermore. And if they are not disqualified, they're in their lane, and their transform.x is larger than or equal to 100, then we announce them as the winner, we quit the game, okay? Nothing too crazy. But on the exam, chances are you're going to be a bit wound up, okay? And you're going to be a little bit tight. That's why it's important to stay loose, okay? Try not to get too panicked, because a lot of these questions aren't that hard, and good ideas will probably just walk right into your head if you're in a good place. So try and stay calm. And if you're not calm, what can you do on the exam? Because you have so much time.
Take a breather.
Yeah, just take a breather. Just stare at the ceiling for a bit, right? Yeah. Yeah, calm down. Stare at the ceiling, okay? Take a sip of water. All right. This one, not a single person got full credit on this last year. All right. Very salty about that. This is a question that is difficult. It has a lot of information here. And you need to understand how our game engine works and how our game engine is structured in order to do it properly. We have 3 resources, images here. You're going to be drawing them, okay, in order to put together some gameplay, okay? These objects are going to interact with each other, so you need to know what that means, okay? When you look at this scene file, level1.scene is the initial scene. We have a player that's named player. It comes from the player template, so we'll want to look up the template to figure out what that means. We have a baddie from the enemy template. We have a second baddie from the enemy template, okay? All right, so what should we do? Let's go ahead and look at what it means to be a player. Another thing to take note of is the ordering of these actors. Why does order of the actors matter in the actors array? Yes?
That's the order you update their components.
Exactly. That's right. That's right. So player will always have all of its components run before the baddie 1 and before baddie 2. Okay? So let's go look at player. The player template is right here. You can see this file. We have a components list here, 1T, 2KC, 3SR. So we have a transform, and we can see this transform will start with an X of 2. Okay? If we look at the transform, the Y is going to be 0. That's the default if nothing is overridden. So we know that this circle, this player character, is going to start on frame 0 at 2, 0. Now, will they stay there? That's the question, okay? Because the player also has keyboard controls, and they also have a sprite render. If you look at keyboard controls, okay, right away when it starts rocking in onStart, it's going to grab its transform. It will check if the player has pressed up or if the player has pressed down, and it will alter the transform component's Y or its to be lower, causing us to go up, or it will increase Y to cause us to go down. There we go. That's what the player is going to do. So let's look and make sure this is right. X equals 2, Y equals 0. No override on the player. So X equals 2, 0, 1, 2, and Y equals 0. Okay, yep, so that's the right place for it to be on that frame 0. There's no input being held during this frame. Okay? Input is decided early on in the frame, right? It's input, update, render in our engines. That's usually how most engines do it. And so the input is really going to be very consequential here. Okay? Next, we need to process the baddie. Okay? So you can see we can just go from character to character and kind of mark out and look at what they're going to do. So baddie 1 is of template enemy. It is going to override something called the 1T component. This is probably the transform. So 6, -1. Let's go look at a baddie. So where's the baddie at? Here's the enemy template, okay? It has a 1T of type transform, an X and a Y, but we don't care. It also has enemy AI, and it also has sprite render, okay? So it's going to be placed initially at 6, -1. So 0, 1, 2, 3, 4, 5, 6, -1, right here, okay? But the enemy is not there. So what's the problem? Well, a lot of students came up to me last year, and they're like, hey, Austin, I think the exam is messed up. Because, you know, the enemy is one off, right? It should be to the right one. At which point I would just kind of solemnly tell them there's no bug here. And I think that's probably giving too much hint, right? I don't think I'm going to give that hint on this coming exam if I need to. But anyway, let's look at what happens because we still have two components. The sprite render is just very standard, does nothing out of the ordinary, no tricks there. The enemy AI component is right here. It grabs its transform, no surprise. If the current frame is even, right, it's doing modulo to check if it's even or odd. If it's even, what it's going to do is it's going to move its X position by -1, which means we're going to the left one block. Oh my goodness, can you believe it? That's why it is one left of where you expect. Because remember, our engines update input, update, render, which means it gets a chance to do that update before the render happens, okay? You get this first frame to basically, I guess, force you to pay attention and figure out how things are going if you're missing some stuff. Anyway, after moving, it checks to find the player, it grabs the player's transform. It checks if the player's position is the same as my enemy position. And if it is, then it grabs the player's sprite render. It changes the sprite to that KO image right here with the X eyes. It then grabs the keyboard controls for the player and disables that component. It then destroys itself. So it destroys itself so the enemy disappears and you just see the defeated player, okay? So that's how it goes, how these things all work. And these enemies, this enemy is right here, right? But this enemy, baddie 2, is actually not going to be on the screen. It's going to be at 9, -2. So it's going to show up because it's going to keep walking to the left. And it's going to show up in this third column, this third row, sorry, from the bottom. And we're going to see it in a couple frames. These enemies only move on frame 0, okay? So the player is going to press up, and so we move it up, and there you go. Now the player's holding it. This is a problem with the exam from last year. It didn't say input being held on this frame, okay? Because everyone made a mistake. On this frame, almost everyone moved the circle up a second time. But we are using input.getKey down, not input.getKey. So the player must release before that input.getKey down will run again and be true again. So this is the thing that actually crushed everyone. Not a single person got this right who didn't then immediately make another mistake. I think we had a handful of people who did figure this out and got it right, but then they messed something else up. So yeah, rest in peace. We've had no one ace 100% the exam. It's a shame. Wouldn't it be cool if that were no longer true on Friday night? That'd be great. Okay. Anyway, we're at an even frame again, so all the characters have moved, okay? We're holding no inputs this frame. I pressed down, so my character has gone down, okay? Because we lifted it up on this frame, we go down again. All the characters have moved to the left again, no surprise. Here, I keep holding down. Here, I've switched to pressing up. Now, up was not pressed previously, so it does cause us to go up. We get a smiley face on this frame. Is that interesting? Why isn't it a dead face? A KO face? This is the second thing that everyone messed up. Yes?
Because the player's sprite render goes before the enemy's collision detector.
Bingo. the sprite render on the player runs and commits, renders that nice smiley face before the baddie can change the sprite render's image. Okay, so the player has a sprite render, it's circle. The baddie touches the player after the player is already done rendering, right? And moves into the player. That causes this image circle to change into image KO. The problem is we've already rendered for that frame, okay? Or we've already done our render call. And so we are happy for now. But next frame, right, we've gotten rid of the box. That's gone. We did not render the sprite render for the box. And we have now go ahead and render the defeated player. Okay, the box moves toward us. We press up, but the keyboard control component is disabled, and so we don't move. And so now this is our ending state. Do you see why no one got this one right? 100%. We got a lot of people got like 9 points, because what happened is if you make one mistake, we just roll with it. We like -1 or -2 you, and we just kind of roll with that and pretend that was actually the right thing to do and see how it plays out. If you make another different type of mistake by missing something else, then we don't give you the credit for that, or we take more points. But you know, I started grading this, and the first few people made the mistake with the inputs on this frame, and like it was immediately -8 or -9. And I was just seeing -9, -8, this person got -7, this person got -9. I was like, oh my God, we have to change how we grade this. Otherwise, everyone is just going to get completely crushed. And they're going to be angry at me because I kind of messed this up. It didn't make this very clear, did I? How the inputs work. So anyway, that's how it simply is. Okay, the final question. Final question I thought was actually kind of hard. This is a question that proposes a new type of lifecycle function that we didn't do in homeworks, but that we could have done in homeworks. This is a question that asks you to create on-entered camera area, exited camera area. These are two functions you might want to use. This actually exists in Unity. I think it's called on became visible, on became invisible. These are lifecycle functions you can use to, for instance, optimize a character. If a character is not visible, maybe you can turn off some components so that you don't have to process as much stuff, more efficient, all that stuff, right? Maybe a character only moves when they're not visible on the camera, like Boo from Super Mario series, right? Well, we show you some Lua code kind of demonstrating how it works and why you might want to use it. You then have to bring these functions to life. So in order to bring them to life, you need access to some engine code. And so we provide a few pages of engine code. You're told more or less what you need to do. Okay, study the next few pages, and then you're given an objective. You are told to add a data structure to this file right here, or add some data, okay? You need to track whether or not you were visible last frame, because these functions won't run repeatedly, right? It's on became visible, on became invisible, right? And so you only run the function if the status was different on the previous frame, okay? So otherwise you accidentally run the functions every frame. That's probably not great for performance, right? Probably not what you want, a bit awkward. You're given a lot of stuff, okay? You're given a lot of stuff in this problem. You are given a function definition, declaration for a function you need to define. You're going to write the code for this. And you're also given some nice convenient data structures. You're given a list of components that have the on-entered camera area function, and a list of components that have the on-exited camera area function. So you can just iterate through these if you ever want to find those components to, for instance, call the function, okay? And you don't have to think or check if the function's there. You just know it's there, okay? It's been pre-populated. It's all good, okay? Down here, you need to write a function that will actually call this. You need to write something that will actually cause this function to be called. The homework tells you when it should be called. It should be called after late update. Okay, after everyone's late update has run, then we should maybe call some of the these functions on the components, okay, after that. So you put that in here, right here. I left you a little bit of room to mess it up if you want to, okay? But maybe it's a little bit mean, but I can't make it too obvious, can I? Otherwise, it's just write the thing in the box, which isn't great. You're given a bunch of helpful stuff. So these draw UI requests are basically requests to draw your character. The way the function works is if we ever draw a character inside of a camera's area where you might actually see the drawing, then we consider that character to either be visible or invisible. You can get the current draw request that exists for a particular actor using this static function. It's public static, which means it's super easy to call, and this is just the engine helping you out, okay? All right. You also have an X, a Y, a W, and an H, which should trigger you. When you see those numbers, you're probably thinking hopefully about homework 6 maybe, which had the AABB implementation, okay? And it's going to show up here, all right? It's kind of hidden in here. Couldn't believe it, right? You have some nice utility functions. Show me you know how to call these, all right? That will give you the camera's height and the camera's width, which you need. And then you're told, basically, use what you've been given, fill in a few gaps here, and then write some code to make it all come to life. So, this is this static? No, this is not. So this is a function that's going to be run automatically on every actor. You are iterating through your actors, and you are calling that function, okay? And so you need to go get the draw request for this current actor. There's only ever going to be one or none, potentially. If it's none, if it's null pointer, right, you need to do one thing. If it's not, the other. If it is, if it's not null pointer, then you want to go in, do some math, do the AABB math to find out if we can see the draw request, if it is in our camera area. And yeah, we have cam width, cam height. I think the assumption is that, yeah, cam is at 0, 0, and it never moves. Otherwise, I could have made the problem a little bit more difficult by also having you get the camera's X and Y position, right? Yeah, visible this frame, false, visible this frame, true. We then check what were we last frame versus what are we this frame. And depending on what we were versus what we are now, we either iterate through all the components that have the on-entered camera area and we call them, or we iterate through all the components on exited camera area and call those, okay? We then just update our variable so we know what we were on the previous frame, and that sets us up with plenty of room to spare. So, yeah, cam H, request X, Y, request Y, request H, yep, so it's using request. Yeah, I sometimes struggle to remember AABB myself, but yeah, not too crazy. The final question here is just draw. Go ahead and name your engine if you haven't already. You can change it later if you want, and then draw a cool little logo. If you ever get too exhausted, you can go to fun questions like this and just kind of chill for a moment, get some points, get your confidence up. That was it. And yeah, for some students that took 4 hours. Most of the students left at about the 2.5 to 3 hour mark. Yeah, but I'd say about 25% of the students were there to the very end, just to kind of squeeze every last drop out in case they got a good idea or something, okay? I think this coming exam will be a little bit shorter. It's a little bit more helpful, I think a little bit less obtuse. And this exam existed. So last year, no one knew what this exam was going to look like. I didn't have a practice exam to give them, okay? Now I do. So, yeah, hopefully it'll be a little bit easier for you. Does anyone have any questions?
So when you said that the new exam doesn't cover any of the same things as this exam.
I don't think I said that. Yeah, there are going to be a lot of familiar things.
Okay, cool.
Like, there are no questions that are literally the same.
Yeah.
But, you know, there's going to be some nostalgia, at least for me. But there's going to be some new stuff. And you're never going to believe this, but some of it's going to feel old, some of it's going to feel new. This is about as useful as the May and Mags are going to show up at some point.
Yeah.
Hint, right?
And so some of feels new, that means it's randomly placed in the heap, so we don't actually know where it is.
Yeah, pretty much. Yeah. Under lock and key. This is a no spoiler zone. No leaks. Got an iron hull. Okay. All right, everyone. I wish you good luck. I'm gonna update the auto graders after the shut-off date on Monday, after 4:30 on Monday. So don't worry about that yet. What else? Yeah, let me know if you have any questions or comments, if anything comes up with the exam. We cannot move the exam at all. So I hope you've done a lot of extra credit if you're going to miss the exam. Yeah. Good luck, everyone. I'll see you later. Okay, office hours will start in like 15 minutes. Take a quick break. Okay, everyone online, I'll see you later, okay? Good luck on the exam on Friday. I'll see you then. Bye-bye.